All right. So now that I started recording, let me just mention again that what I'm going to be doing today is showing a pre-recorded video on hypothesis testing that I did last semester. I'll play part of it today and part of it on next Tuesday, the rest of it next Tuesday, and then we'll start working in StatKey to show you how to do what are called hypothesis tests in StatKey. But I do believe that you need to have a good introduction to what a hypothesis test is, and that's why I'm going to show you this video. All right, and there are also in another textbook that I use, there's also a couple PowerPoints that also I will post, which you can go through also. So if you want something written, these PowerPoints also review the basics of hypothesis testing. None of this, by the way, requires any formulas or anything. It just, you do need to have this background. Otherwise, what you do in StatKey won't make any sense to you. All right, so let me share the screen. I'm going to share the computer sound also so that you can hear. And let me find this video. So, and I'm going to put myself on turn my video off so you can see this. You know, watch me, watch you. All right, and make sure you pay attention to this. It's very important to pay attention. All right, so we'll get started. Give me a thumbs up if you can hear the video.
Well, hello, everyone. This recording is for this week, for Wednesday, November I guess it's the 25th. And purpose of this recording is to give you an introduction to a new topic called hypothesis testing. I'm recording this not only for my statistical literacy classes at Rowan University, but also for my Introduction to Statistics class at Camden County College. Both classes are starting hypothesis tests at the same time, so I thought I'd do this recording for both of you. For statistical literacy, the introduction, I will show you things without formulas. There won't be any formulas because when you actually do these hypothesis tests, you're going to be using StatKey. There's something called a randomization hypothesis test that we're going to do in StatKey, which I will start showing you next week. For Camden County College class, you'll be learning the traditional way of doing hypothesis tests. So you will be learning with formulas. Okay, so that's the distinction between the two classes. But for both of classes, this is a nice introduction. Now, one of the things I will be doing tonight is I'm going to be showing you a video. This comes from a video series on statistics by Professor Williams. This video comes from also, these videos actually come from a company called The Learning Company. And they do a series of courses called the Great Courses. So anyway, this course, in my opinion, is an advanced introduction to statistics course using the R programming language. Obviously, for our statistical literacy course, this is not something that we're going to be pursuing. Even for the Camden County course, this goes a little bit beyond what you guys are doing too. However, Professor Williams does a very nice job in the first 11 minutes and 40 seconds or so of this video, introducing you to the topic of hypothesis testing. So I'm going to let her talk about this with you first, and then I will continue. I've created a PDF document, which I will post in Canvas for both schools, both courses. And that will go into just slightly more detail than Professor Williams does, but she does such a nice job in introducing this topic that I thought I would share her introduction with you. All right, so let's do that first. All right, so let me just stop share in a second here. I just have to find her video. There we go. Just give me 1 second here. Set up the share screen. There we go. All right. So I will make sure that the computer sound is also shared so you can hear it. All right. And here it goes.
The past few lectures have been about parameter estimation. How do we use our sample data in order to estimate a population parameter, like the mean? So we learned that we can take our sample mean and we can use it as a point estimate of the population mean. And we could even build a confidence interval around that estimate. And so this confidence interval would be where, say, 95% of the time, we would cover the true mean. But there's another way that we can look at our data. Instead of using our data to estimate a population parameter, we could instead guess a value of our population parameter and then ask ourselves, do we think our sample could have come from that particular population parameter? So instead of going from the data to the parameter, we could actually go vice versa. We could go from the parameter to the data. We call this new approach hypothesis testing. Now, we do hypothesis testing practically every day in real life. In fact, every time I go grocery shopping, I'm likely to do a hypothesis test. In fact, here's one time when my hypothesis test didn't quite go so well. Now, my family loves a particular type of almond milk. And, you know, I'm going to the store and I'm shopping for it one day, and it's the sweet vanilla kind. Okay. So I'm in the grocery store and I notice there's a different brand of almond milk and it's on sale. I mean, it's like a good sale. It was $1 off. And so I'm thinking, okay, it's the sweet vanilla kind. It's just a different brand. It'll probably taste just as good. And it's $1 off. So we're fixing breakfast for our 3 boys the next day, and I take out this new brand of delicious almond milk. No big deal. They're young. What do they know about almond milk anyway? And it was $1 off. Well, to put it nicely, they hated it. I mean, their faces got contorted and nobody finished their cereal. And as you can imagine, I have never bought that brand again. So what was my hypothesis? Right? It was that this brand new almond milk is just as good as the old brand. And what do you think my sample data was? Well, that was my 3 sons' reaction to this new milk. And did my data support the hypothesis? Absolutely not. In fact, my data flat out rejected my hypothesis. So what is a hypothesis? Well, in general, a hypothesis is just an educated guess about something in the world around you. Maybe something that you can be able to test or experiment with or observe. Now, in hypothesis testing, what we really want to know is whether the characteristics of our sample match the underlying characteristics of our assumed population. So with the milk, my assumed population was that, oh, it should be just as good as the old brand, right? The new brand is good as this old brand. But is sampling just 3 people sufficient? Now, at our breakfast table, the samples weren't even independent. Maybe one of them in the 3 were influential over the others. And it's not enough just to do a visual comparison, right? We need a quantitative way to evaluate our sample relative to some baseline. And that's what statistical hypothesis testing is going to do for us. Now, formally, a statistical hypothesis test is a claim about our population parameters. And when we do hypothesis testing, we're going to start with 2 pretty contradictory hypotheses. The first is our null hypothesis. We call that H naught. Now, this is the claim that's initially assumed to be true. It's like our prior belief, our old theory, the status quo, the current standard. And then there's the alternative hypothesis. We call that HA. This is our contradictory claim, the competing claim. Maybe it's the new theory or some alternative standard. And so we need a way to decide between the null hypothesis and the alternative. And this is what our decision principle is. We're going to reject the null hypothesis in favor of the alternative if our sample shows some strong evidence that that null hypothesis is false. Otherwise, we don't reject it. Statisticians also say we failed to reject H naught, like it's a failure if we can't reject the old theory. Now, hypothesis testing uses our sample data to make decisions about the population. We can specify our testing procedure with the following. So first, we're going to need a test statistic. Now, this is going to be some function of our sample data that we're going to use to make a decision, right? Whether or not we reject or fail to reject the null hypothesis. So that decision is going to be based on this test statistic that we calculate from our sample. Secondly, we need a rejection region. So this is going to be the set of all test statistic values for which the null hypothesis would be rejected. And then finally, we need a decision rule, right? So we're going to reject our null hypothesis if our test statistic falls in the rejection region. Now, the null hypothesis is assumed to be true, and we have to provide the statistical evidence needed to reject it, right, in favor of the alternative hypothesis. Now, if you've ever had jury duty or watched a court case on TV, then you've seen hypothesis testing in action, seriously. So in criminal trials in the United States, the defendant is innocent until proven guilty. So in other words, our initial assumption is that the defendant is innocent. Now, let's see what hypothesis testing looks like for a population mean. In this case, the null hypothesis is that the mean of our sample is equal to the mean of the population. So mu is equal to mu naught. Now, this is assuming that the null hypothesis is true. Now, we often test whether our sample mean is different from 0. So H naught, that mu is equal to 0, would be our null hypothesis. The alternative would be that mu is not equal to 0. Here are a couple of examples of alternative hypothesis. We could test that our alternative is greater than mu naught, the mean under the null hypothesis, that is less than the mean under the null, or that is not equal to the mean under the null. Now, there are two types of errors that come up in hypothesis testing. The first is a type 1 error. In this case, we're going to reject the null hypothesis when it's actually true, right? We call this a false positive because we think we found something new, but we actually didn't. Another type of error that we make is a type 2 error. This is when we fail to reject the null hypothesis when it's actually false. We call that a false negative, right? Because now we've missed some new result. Now, we have two terms, alpha and beta. Alpha is going to be our probability of making that type 1 error. And beta we call the probability of making a type 2 error. Now, you can imagine we want to keep these as low as possible. But there's a contradiction, right? As soon as we try to balance the probability of making a type 1 error, well, it changes our probability of making a type 2 error, right? So we can decrease the rejection region and get a smaller alpha level, but a smaller alpha level is going to give us a larger beta, right? So our type 1 error, this is usually the one that's more serious to us than the type 2 error. And here's why. All right, let's go back to the criminal trials. We're in the United States. And again, we've assumed that our defendant is innocent until we prove them guilty. So in this case, what's our null hypothesis? Well, that would be that the defendant is not guilty. They're innocent. The alternative is that the defendant is guilty. Now, we always assume the null hypothesis is true unless we've got sufficient evidence, right, beyond a reasonable doubt to reject it. So in hypothesis testing, our data are the evidence, right? If there's enough evidence in our data, we reject the null hypothesis. And if there's not enough, we fail to reject. So in this case, a type 1 error would be like convicting an innocent person, right? The evidence led to a wrong conclusion. And if we made a type 2 error, that would be like setting a guilty person free, right? There's not enough evidence to prove guilt. But because we want a just and fair process, we assume that everyone is innocent, right? Until they're proven guilty beyond a reasonable doubt. And the proof is going to be in that data, this large body of evidence that's going to be presented to suggest whether this person committed a crime or not. Now, if we wanted to say control for the type 2 error, meaning we would never set a guilty person free, we would also end up convicting a lot of innocent people. On the other hand, if we control for the type 1 error and never convict an innocent person, then we end up setting guilty people free as well. So we typically choose the largest alpha that we can tolerate. Let's say alpha equal to 0.05. So what this means is we're willing to mistakenly convict an innocent person 5% of the time in exchange for making the right decision 95% of the time. Now, if we couldn't tolerate that, we could also choose a different level alpha, maybe alpha 0.01. So then we'd mistakenly convict an innocent person 1% of the time, right? And correctly make the decision 99% of the time. We call that alpha our significance level. All right, let's look at the following types of hypotheses. And I want to kind of prep you for where we're going to go with this. 3 ways that we look at hypothesis testing. And first is an upper tail test. So the null hypothesis is that mu equals mu naught, some mean that's assumed under the null, versus the alternative is that our sample comes from a population that has a mean that's greater than the mean under the null. So mu is greater than mu naught. A lower tail test is the opposite of that. Now we're assuming that our sample comes from a mean population that might have a mean that's less than the null. So that's our alternative hypothesis. And then lastly, we can do a 2-tail test. Now we're looking to see if our sample is different from the null, either greater than or less than.
Okay, so I'm going to stop the video right there because she's going to start getting into some technical things that are for formulas. And again, for all of you who are taking my statistical literacy course, we're not going to be doing hypothesis in that way. You probably are saying thank God for that. For Camden County students, you'll be using your formulas, so, but you're already excited about that, I'm sure. All right, so let me now share with you the PDF that I've set up for this. Basically, now that she's described a little bit about hypothesis tests, and hopefully much of that made a great deal of sense to you, I'm going to give you just a little bit more detail on it. So let's get to the PDF that I've set up. All right, so she talked about 2 types of hypotheses: the null hypothesis, which is basically the hypothesis that is accepted right now. So it's basically what people generally accept. And then we have the alternative hypothesis, which is a competing hypothesis. It challenges the null hypothesis. Now, when we actually write these hypotheses, number one, we have to know that the hypotheses are claims about populations, not about samples, all right? So as she mentioned, we're going to use the sample to test whether a claim about a population, basically the null hypothesis, whether there's enough evidence to reject it or there is not enough evidence to reject it, all right? And when we do reject the null hypothesis, we're going to end up going with the alternative, the competing hypothesis. Now, just for some practicalities, you might have seen this on the video, but I'm going to mention it to you again. And I'll post this, obviously, so you can see it in Canvas. This is the way we write. This is a symbol for our null hypothesis. It's H, and sometimes people call it H naught, naught meaning 0, or H sub 0. But it's a big H with a little 0 down next to it. Okay, so that is the symbol for our null hypothesis. Now, our null hypothesis always has an equal sign in it, right? It doesn't have less than or greater than or not equal to, always the equal sign. So an example would be our null hypothesis H naught is mu, which is our population mean, is equal to 5. That's one example of a null hypothesis. So this is a case where we have a measurement variable, one that we are measuring something. So we have mu as the population mean that we're testing. If we're looking at proportions, we're going to use the letter P to represent a population proportion. So mu represents a population mean. P represents a population proportion. If we're testing that, it would be P equal to 0.35 as an example of a population proportion that we're testing. Now, the alternative hypothesis, once again, is a research hypothesis that challenges the null hypothesis. And the symbols that we typically use in it will be either greater than, or less than, or not equal to. All right? We never use equal to in the alternative hypothesis. All right, so this is very important to understand that. The symbol that we're going to use is H with a small a next to it. Typically, people pronounce it H sub a, but that's the alternative hypothesis symbol. Now, typically, you put a colon next to it, and then you put the alternative hypothesis next to it. Now, remember, the symbol is either going to be greater than, less than, or not equal to. Dr. Williams was mentioning that right near the end of the video that I showed you in those 3 cases that she was referring to. But some examples would be, for example, if we were testing a population mean of 5 in the null hypothesis, we could, as a competing hypothesis, either have mu greater than 5 as the competing hypothesis, mu less than 5, or mu not equal to 5. Right now, 5 is just some number I picked. All right, that doesn't mean anything. It's just a particular number. Or, as an example of a population proportion, if the null hypothesis is P is equal to 0.35, then one of these 3 would be the alternative hypothesis. Either P is greater than 0.35, P is less than 0.35, or P is not equal to 0.35. All right. Now, when these hypotheses are written, the null hypothesis will have a number next to the equal sign. It could be a mean, or it could be a proportion. That number must match the number shown in the alternative hypothesis. Can't be a different number. It has to be the same number. So 5 is here. 5 has to be in one of these 3. Same thing here. The proportion is 0.35 with a null. 0.35 is one of these 3 that's chosen as the alternative hypothesis. They have to match. All right, so that's important. Dr. Williams did not mention that. Now, she did mention that when we do hypothesis testing, she used the example of criminal trial. We assume that the null hypothesis H naught is true. All right, it's the standard knowledge about something, whatever we're measuring. All right, something quantitative in nature. We're assuming the null hypothesis is true to begin with. And then we take our sample data, and we want to see if the sample data that it provides enough evidence. In this case, we would call it enough statistical evidence to say that the null hypothesis is highly unlikely, and therefore we're going to reject it in favor of the alternative hypothesis. So we would say accept or the alternative hypothesis. So if there is enough evidence, we state that the alternative hypothesis is statistically significant. That's another term for accepting the alternative hypothesis, is that if there is enough evidence and we reject the null hypothesis, we will be basically saying that the alternative hypothesis is statistically significant, meaning that there's enough evidence to say that is the competing hypothesis is probably correct. Now, if there's not enough evidence statistically, then we do not reject the null hypothesis. This is not the same thing, and so we do not accept the null hypothesis, all right? We do not accept the null hypothesis as true, since it can still be false. All right, now what does that mean? Now, when I say we do not accept the null hypothesis, it means we don't use the word accept, all right? In other words, if there's not enough evidence, we would say we do not reject the null hypothesis, okay? We do not say we accept the null hypothesis is true. Now, what do we mean? Well, let's think about a criminal trial. Somebody let's say the person committed a crime, whatever the crime might be. However, the district attorney, you probably watch television, the district attorney didn't have a good enough case, didn't have enough evidence to convict that person. So the jury basically said, not enough evidence, we're going to let the person go. So what has happened? Well, there's not enough evidence to reject the null hypothesis. So what happens? The person goes free, right? The null hypothesis, the person is not guilty, and we didn't have enough evidence to reject that hypothesis. The person goes free. But it does not mean that person was not guilty. It doesn't mean that. It just means there wasn't enough evidence to convict a person. It's still possible that person committed the crime. In the same way, we don't have enough evidence from our data to reject the null hypothesis. We don't say, well, we're going to accept the null hypothesis as true. No, we just didn't have enough evidence to reject it. So we say, we do not reject the null hypothesis. We do not accept the null hypothesis as true, okay, since it can be still false, despite a lack of evidence in the data. All right, so I hope you understand what I mean by that we don't make the statement something like, all right, not enough evidence to reject the null hypothesis, therefore I'm going to accept the null hypothesis true. No, we can't say that. Right? It's still possible the null hypothesis is false. So what do we say? We don't reject the null hypothesis due to lack of evidence. That's what we say. All right. Hopefully that's somewhat clear to you. And again, these sort of things I will repeat over and over again. We do actual examples, so don't worry about it. Now this chart here is a typical chart that's shown in most statistics books that looks at a comparison of two things. On the left here, we do our statistical test. Now, for those of you who are in the Camden County course, the traditional statistics course, this will be an actual formula that we'll be using to do this test. For those of you at Rowan University in the statistical literacy course, we'll be using StatKey instead. But regardless of what we're using, we're going to have a test, and we're going to see the result of the test from the sample data. All right. Regardless. And there's either two decisions from that test. Either we're going to reject the null hypothesis, all right, and there's enough evidence to reject the null hypothesis, and therefore we'll accept the alternative hypothesis. Or, and that's called significant results, or there's not enough significance, not enough evidence to reject the null. And that's that decision. So we either reject the null or we don't reject the null. Those are the two decisions. Now you have to remember we have sample data. Sample is a subset, a small subset of the entire population. And typically when we do hypothesis testing, we really don't know anything about the population parameter in general. We don't know what the true value is. Otherwise, we wouldn't bother with the test. So in reality, it's an unknown reality of the actual population parameter that we're testing. It's unknown. So in reality, either the null hypothesis is true or the null hypothesis is false, and the alternative is true. So, but that's unknown. It's unknown. So I hope you understand these two different things here in this chart. Along the left here is the result of the statistical test. We're either going to reject the null hypothesis from the data, or we're not going to reject the null hypothesis. Up here, along these columns here, is the actual unknown reality. In reality, either the null hypothesis is true or it's not true. Simple as that. Now, Dr. Williams mentioned two types of errors that are possible in a hypothesis test. The first one is called a type 1 error. It's in this box here. See, there's 4 boxes. This box here is an intersection of this row, where we're rejecting the null hypothesis, and this column, where we are stating that in reality, the null hypothesis is true. So this is an error, right? If our test says there's enough evidence to reject the null hypothesis, and yet in reality, the null hypothesis is
Okay. All right, so we have 1 more minute for the quiz, and see if there was another chat message. No, it's the same. The answer is no to the question from Anika. Yeah. They don't have a course like that there. All right. All right, so 1 more minute for the quiz. Make sure you turn your videos on. And when it hits 8:40, just give me a thumb up. It's 8:40 now. Give me a thumbs up that you see the quiz. Yes, see it? Yes, good. Now, one thing, this quiz is a little bit different than the other quizzes in that there will be fill in the blanks and also a true false. The first, all right, fill in the blanks, and this last one is true false. So this is not, so you actually have to type in your answers for the first 4 questions. Okay, so just type them in. It should be pretty clear when you read the question what you need to type in. The numbers are either usually displayed, or you have to do a little calculation and just type the numbers in. And then there's some choices to maybe make, yes, no questions, true, false questions, things like that. All right, so let's get going. And if you have any questions, send them through the chat. And again, you have 30 minutes to complete this.
When you say the bootstrap sample is equal to, are you just saying like how much is it?
Yeah, I'm stuck
Give me
on
the
that.
exact words that it says. What does it say?
Okay, well, the first, hold on, let me go back. The number of bootstrap samples is equal to blank.
Number of them. Count them. That's what it's asking you to do. The number means count. How many of them are there?
Yeah, okay, so that's,
Okay. Obviously, you don't have to count them. The numbers on the chart. Okay.
Hello, Professor. Professor.
People are taking a quiz right now. Please send it your message to chat, please.
All right, thank you. Sorry about that.
Can you turn your mic off? Sorry.
Sorry.